doing 10.7 exponential growth and decay, and there are three types of word problems you can run into tonight. There's the compound interest problem, there could be a doubling problem, which would be your growth, and there could be a decay problem, which would be like your half-life. So there's three different ones, and the first one I'm going to talk about is the compound interest. If you have any problems that are talking about investing money in a bank and it's going to compound annually, those kind of things, that is this type of problem, and you would have to use this formula right here, and this is the compound interest formula. A stands for your amount. That's how much money you have after a certain amount of years. P is your principal. That's how much money you're starting with. So if you go to the bank and you give them money and they're going to invest it for you, A would be how much you get out at the end, and P is how much money you started with or you put in. You have 1 plus R, and R is your rate, and that's talking about your annual rate. So like, what's your interest rate? I'm sure you've kind of heard of that before. That's your R, and N, like how much percentage you're going to make on your money. N is times per year, and I think I wrote it as T, but this is actually your N, times per year. So how many times is it going to compound, which means how many times is it going to compound quarterly, annually, semi-annually, and it will be stated in the word problem. And T equals your time. How long are you going to leave the money in there? A year, 2 years, 10 years, 20 years, 20 months, those kind of things. So keeping that in mind, we are on page 483, and we're going to do example 1 from the notes here. It says, how long will it take an investment of $1,000 to triple in value if it is invested at an annual rate of 12% compounding quarterly? So how long will it take an investment of $1,000? So you have $1,000, so you're going to invest that. So that's your principal. That's how much you're starting with. You're going to put it into the bank. And you want it to triple in value. So that means that if I multiply this by 3, I want to have made $3,000. So I want my investment to triple in value. So how long will it take an investment of $1,000 to triple in value if it is invested at an annual rate? So you're talking about your rate, your R, an annual rate of 12% compounded quarterly. And this is the part where I'm talking about the compounded. It's compounded quarterly, which means 4 times a year. There's 4 quarters in a dollar, 4 times a year. So N is 4. So we're going to plug this in, but I want to make sure that I always write this as a decimal. So I have to move my decimal over twice, and it's 0.2. And I'm going to plug it into my equation or my formula here. I have 3,000 equals my principal, which is 1,000, 1 plus 0.12 over my compounded quarterly 4 times, and we don't know what the time is. And we don't know, because it says how long will it take? Well, we don't know. So all we know is that we need to make $3,000. So we got to see how long it's going to take. So we have to solve this problem. The first thing I would do was I would divide everything by 1,000. So I can get rid of this and just focus on the parentheses and my exponent. So 1,000 goes into 3,000 3 times. Then I'm going to look at what is inside my parentheses. that, I have 1 plus 0.12 divided by 4. So I have 0.12 divided by 4 is 0.03. And 1 plus 0.03 is just 1.03. And it's still to the 4t, and it does equal 3. So now, I'm going to use my laws of exponents, and I'm going to bring this guy down here to the front. So I have 3 equals 4t. And remember, what you're doing, and I should probably explain this a little better, is that you're taking the log of both sides, because we're going to try to solve this. So I think it'd be easier if you see it like this. So I'm going to take the log here and the log here of both sides. So I'm going to have log of 3 equals log of 1.03 to the 4t. And I know with my laws of exponents that I have to move the 4t in front. So I have 4t log 1.03. I'm going to divide, I got to solve for t, so now I'm going to divide by 4, so I've crossed the 4's off, and log of 1.03, so 4 of log 1.03, so these will be gone, and I'm going to have t equaling, oops, where did it go? T equaling the log of 3 divided by 4 log of 1.03. So t equals this whole thing. So now all you have to do is plug it into your calculator. So you have the log of 3. I get 0.4771. When I do the log of 1.03 and then I multiply that by 4, I get 0.0513. Dividing these two, you get 9.3 when you round. So it's going to take you 9.3 years to come up with $3,000. So we solve for t. Let's go into example number 2. This is going to be an example of a half-life problem or decay. Your formula is n equals n, and it's called n naught. It's just the way you say it. It's not the word no. It's just a little tiny 0. So n naught 1 half t over h. Now, in this particular problem, n is going to represent the amount, and usually it's talking about bacteria or something, and you're trying to like get rid of it, and so it's talking about how long does it take for you to reduce the number of bacteria that's in the jar. That also works with growth. How long does it take for it to multiply? So n is going to be the amount. N naught is the original. How much did you start with? T is going to equal time, and h equals the half-life. So let's look at example number 3 on page 485. It says the half-life of carbon 14 is 5,730 years. How much of a 10 milligram sample will remain after 4,500 years? So it tells you that the half-life of carbon 14 is 5,730 years. So that's literally your H, because it said what your half-life is. So 5,730 years. It says how much much of a 10 milligram sample will remain. So how much will a 10 milligram sample remain? So 10 milligrams is your original, because that's how much you're starting with. This is an H, this is going to be an N naught. Will remain after 4,500 years. So your time is 4,500 years. You want to make sure that these two things, your half-life and your time, are in the same unit. If one of them says that it's months, then you have to convert it either into years or months. So if you had 1 year and 1 in month, you would have to convert them so that they're the same. And it doesn't matter which way, you just need to make sure that if you're talking in years, they're both in years. If you're talking in months, they're both in months. So, we are going to plug in what we know. We don't know how much will remain, but we know that our original was 10. We have our 1/2. Our time was 4,500 years, and our half-life was 5,730 years. So we would go ahead and solve this, and we would have 1/2 to the 4,500 divided by 5,730. Multiply by that by 10, and in your calculator you should get 5.8. And that would be your units would be milligrams. Let's do one more. This one is going to be on decay. If you, or not decay, we just did decay, doubling, excuse me. Look at example number 2 on page 484. For your doubling formula, or you can call it time growth, you have the formula N equals N naught times 2 to the T over D. N is going to be your final answer, like how much you want to get, your amount at the end. N naught is going to represent your original. T is going to equal your time, and D is going to be your doubling. How long it's taking to double. So when you look at example number 2, it says that a certain bacteria population doubles in size every 12 hours. So we are doubling in size every 12. So that's our doubling every 12 hours. By how much will it grow in 2 days? So your time is 2 days. If you notice here, you don't have the same units. You also don't know how much you're starting with. And you also don't know how much you're going to end with. So you're going to have to keep this part of your formula in your answer because you don't know what it is. It didn't give you enough information to fully get an actual decimal or number answer. When you look at this, we already talked about how these are in the same units. So we need to either convert our days into hours or convert these hours into days. So you know that there's 24 hours in a day, so that's 48 hours. So we've converted days into hours. You could have done it the other way around. So let's looking at our formula. We don't know the final answer or the amount. we don't know how much bacteria we're starting with. We know that we're doubling it. We know that our doubling time is 48 hours. And, our time that we're allowing it to double is 48 hours. And our doubling time is 12 hours. So we're going to have 2 to the 4th power, which is 16. So we have 16 times n naught, because we don't know how much we started with, would equal our final answer. So you can leave your answer in terms of n naught if it doesn't give you enough information.